we have two volatile liquids. Okay, one is A in this container and there is another volatile liquid B in another container. Okay, and suppose this is exerting a vapor pressure of PA0 and this is exerting a vapor pressure of PB0. अगर हम इन दोनों सॉल्यूशंस को मिक्स कर देते हैं एक दूसरे कंटेनर में, then it will have the molecules of A and B both, and it will exert some pressure that is given by Raoult's law, that is P total, that is partial pressure of A plus partial pressure of B. And what was PA as per Raoult's law? That is PA0 into XA, and what is PB? That is PB0 into XB. So this was as per the Raoult's law. अब ये अगर solution ideal है तो it will follow the Raoult's law. That means अगर हम इस solution का pressure measure करें, then ऑब्जर्व प्रेशर जो होगा हमारा दैट विल बी इक्वल टू ऑब्जर्व प्रेशर. अगर मान लो इसका प्रेशर मेजर करें मैनोमीटर से तो जो प्रेशर आएगा इफ इट इज इक्वल टू PA0 XA प्लस PB0 XB, देन वी विल से दैट दिस सॉल्यूशन इज आइडियल सॉल्यूशन. ओके, सो दैट मींस इट इज फॉलोइंग द राउल्ट्स लॉ. अभी हम डिस्कस करेंगे कि आइडियल सॉल्यूशन होने के लिए क्या कंडीशन नेसेसरी है, व्हिच सॉल्यूशंस वी कैन कॉल एज आइडियल सॉल्यूशन. सो एज ए डेफिनेशन वी कैन से दैट दोज सॉल्यूशंस which follow Raoult's law at all concentrations and temperatures, they can be called as ideal solutions. So this is the definition for ideal solution. यानी अगर हम दो liquids A और B को mix करें तो जो उनका solution बनेगा, that vapor pressure exerted by that solution that should become equal to the vapor pressure that is calculated as per the Raoult's law. Then it will be called ideal solution. अब ideal solution होने के लिए क्या क्या conditions होनी चाहिए? Suppose again I take that example. Suppose there is a container having liquid A. This is your liquid A and this is having liquid B. अब जब हम इनको मिक्स कर देंगे तो we will get a mixture having molecules of A and. अब होगा क्या, इसके अंदर जब ये प्योर लिक्विड A था, these interactions were between the molecules of A and A. So it was having A interactions. What is intermolecular force of attraction? That is the van der Waals force of attraction between A molecules of A and A. Similarly, this liquid B will have BB molecular interactions. Okay, when we mix the two solutions, the interactions of AA will be broken, the interactions of BB will be broken, and new interactions of AB will be formed. यानी जब हम liquid A separate था तो इसके अंदर molecules of A and A were having some interactions, and similarly B and B molecules were having some interactions. But when we mix the two liquids, this mixture will have the molecules of A and B both. So now the interactions will be between A and B. Okay, so if these interactions are almost same, that means AA interactions is equal to AA is equal to BB interactions is equal to AB interactions. अगर ये interactions almost same है, then we will say that these liquids A and B form an ideal solution. Okay, why it is so? Because if we mix the two liquids, then final volume of this mixture, if we say V final, that will be equal to say this is volume V1, this is volume V2. Then V final will be equal to V1 plus V2. Okay, and this delta will be 0. That means V final equal to summation of the two. Okay, so we can say that delta V mixing is 0 in case of ideal solutions because the interactions are almost identical. So the volume will neither increase nor decrease. So what are the conditions that this ideal solution will satisfy? Number one is delta V mixing will be 0. That means there is no change in volume of the solution after mixing the two liquids. Number two, delta H mixing will be 0. That means there is no enthalpy change on mixing of the two liquids. So it is neither exothermic nor endothermic. Number three, we can say that the vapor pressure exerted by the solution, vapor pressure of solution is same as that predicted by Raoult's law. That means it obeys Raoult's law. So its vapor pressure is observed vapor pressure. What we actually see after measurement is found to be equal to say PA0 XA plus PB0. So these three conditions it has to satisfy. And what is the main condition? The molecular interactions, that is intermolecular forces of attraction between the molecules of A and that between B and B should be almost same as that between molecules of A and B. Okay, so that is the prior condition. If that condition is satisfied, then all these three will be satisfied. Then we say that this is an ideal solution. Okay, now we will ask that there is another two conditions. That is delta S mixing, it will be always greater than 0, whether it is ideal solution or it is non-ideal solution. That is the entropy change on mixing will be always positive. Because when we mix the two liquids, the number of molecules will increase, so the randomness will increase, so the entropy change will be positive. And similarly your delta G mixing, that is the Gibbs free energy change on mixing will be less than 0 because this process is spontaneous. So these are the conditions that are to be satisfied by the ideal solution, and these two conditions they hold for both ideal as well as non. Okay, so now we take some examples of ideal solutions. After that we will take the non-ideal solutions. So let us take some examples of ideal solutions. First we have to see that both the solutions, both the liquids should be of identical nature. Say polar, if one liquid is polar, then other should also be polar. Okay, if one is non-polar, then other should also be non-polar. Why so? Because the intermolecular forces of attraction need to be identical. Then only this solution will behave as ideal solution. So if we take one polar and one non-polar, then these molecular interactions will be significantly different and the solution form will not be an ideal solution. So let us take some example. Say I take the example of say methanol plus ethanol. So they will form an ideal solution because both are having hydrogen bonding of the same extent and both are polar molecules. Okay, and suppose I take two non-polar molecules, then also they will be like say I take benzene plus toluene. So both are non-polar. So they will make ideal solution. And the difference in their molecular masses is also not much high because they are just adjacent in a homologous series like your methanol and ethanol. If I take say methanol plus propanol, that is C3, then they will not form ideal solution, they will form non-ideal solution. Why? Because the molecular interactions will be significantly different because of the size change is very high. Means the molecular mass of propanol is significantly higher than methanol, so the van der Waals forces between the two will be significantly different, so they will not form an ideal solution. Similarly, say I take benzene plus say xylene, instead of toluene I take xylene, then also it will not form ideal solution, it will form non-ideal solution. Okay, and these are the ideal solution, this is also ideal solution. If I take say N-hexane plus N-heptane, that will also form ideal solution. Okay, say I take C2H5Cl plus C2H5Br, that will also form ideal solution because they are chlorine and bromine both are adjacent to each other in the group. So with this we know that which solutions can behave as ideal solutions and which can behave as non-ideal.